Two-stroke engine, how does it work? Have you ever wondered how a two-stroke engine operates? Let's break it down in simple terms. A two-stroke engine completes a full power cycle in just 2 movements of the piston. This means one upstroke and one downstroke happen in a single revolution of the crankshaft. This is different from a 4-stroke engine, which needs for piston strokes over to crankshaft revolutions to finish a cycle. The action begins with the piston moving upward. As it rises, it compresses the fuel-air mixture inside the combustion chamber. This compression happens without any heat exchange with the environment, which is known as an adiabatic process. When the piston reaches the top of its stroke, the spark plug ignites the compressed mixture. This ignition causes combustion, which rapidly increases the pressure and temperature inside the chamber. This process occurs at constant volume, leading to a sharp rise in pressure. Next, the high-pressure gases push the piston downward during what is called the power stroke. This is where the thermal energy from combustion is transformed into mechanical work. As the piston descends, it uncovers exhaust and intake ports located in the cylinder walls. The exhaust port opens first, allowing burnt gases to escape, while the intake port opens to let in a fresh fuel-air mixture. This simultaneous action is known as scavenging. Because the intake and exhaust processes overlap, a two-stroke engine produces a power stroke with every single revolution of the crankshaft. This results in a higher power-to-weight ratio compared to 4-stroke engines. However, this design does come with trade-offs. It often leads to lower fuel efficiency and higher emissions, as some burned fuel can escape along with the exhaust. Mechanically, two-stroke engines are simpler. They do not have the complex valve systems that 4-stroke engines do. Their lightweight and compact design makes them ideal for applications like motorcycles, chainsaws, and small outboard motors, where power-to-weight ratio and simplicity are more important than fuel economy and emissions. From a thermodynamics perspective, the two-stroke engine cycle involves several key steps. First, during the upward movement, the fuel-air mixture is compressed adiabatically. Then, ignition occurs, rapidly adding heat at constant volume, which increases pressure. During the downward movement, the expansion of gases does work on the piston. Finally, the exhaust gases exit while fresh mixture enters, all happening simultaneously. This cycle effectively converts the chemical energy from fuel into mechanical energy, but it does have some drawbacks in terms of efficiency and pollution control compared to 4-stroke engines. Understanding how a two-stroke engine works helps clarify its role within the larger context of internal combustion engines and thermodynamic cycles.